Hello everyone, I'm Norman Wildberger, and this is part of the Sociology and Pure Mathematics series, where we investigate pure mathematics from a humanistic perspective. And today I want to talk more about Euclid. I talked about him a little bit in the context of some of his number theory work, but actually the majority of his work was in the direction of geometry, and we need to make contact with that long historical tradition. So it's important to recognize that we are not just an isolated discipline, that a snapshot now in time can really capture. We have to see mathematics as part of an evolutionary process going back thousands of years. And I've emphasized that this is quite a unique aspect of mathematics, not shared so much by other scientific disciplines. Euclid lived around 300 BC, and for more than 2,000 years, until the latter part of the 19th century, it was the dominant text in mathematics. And since then, its importance has dropped down dramatically, so much so that now undergraduates are barely even aware of Euclid, and most of them will never have actually opened Euclid up. So we want to kind of go back and see the importance of Euclid. And I'm going to do that by giving you an excerpt of a lovely book that I have. So this is actually an edition of Euclid that was published in 1723. It was it's a book printed for Thomas Woodward at the Half Moon over against St. Dunstan's Church in Fleet Street. And it's Euclid's Elements of Geometry from the Latin translation of Commandine, who I believe lived from 1509 to 1575. And I want to today talk about Dr. Keil's preface to this work. So Dr. John Keil was somebody of independent interest. He was a rather important mathematician of the 17th century. So he lived from 1671 to 1721. And he was a mathematician, but also an astronomer and a notable defender of Newton in the famous controversy with Leibniz over the origins of calculus. He became Savilian Professor of Astronomy at Oxford. And he was, of course, very interested in geometry, as this excerpt shows. So I want to read you this. Okay, it's quite interesting. We're going back to almost 300 years ago. He died actually just a little bit before this book came out. He died in 1721, 2 years before the book came out. So this is going to be, I think, quite interesting, and there's several notable things about it. One thing that actually surprised me is just the way, the style of the text. So in this style here, the letter S is often written in a German style with a long kind of integral sign. There's also ordinary S's, but then there's also these elongated S's. That's quite interesting. Another aspect that I think is very interesting, that I'm actually quite fond of, is the idea of using capitalized letters to symbolize nouns. This is a very Germanic tradition, and it's adopted here. So whenever there's a noun, it's in capitals. And I think that's quite interesting. Another small innovation, something that was novel to me, is that at the bottom of every page, the last line, just on the right-hand side below it, there's an extra word, and that's the word that starts the next page. Sort of giving you a clue, if you're sort of turning the page, as I'm going to be, what the next word that you're going to say is. It's quite interesting. Okay, so we're going to go back to 1721, probably something like that, about 300 years ago, after Euclid has already been the dominant mathematical text for close to 2,000 years, spanning a lot of different cultures. Okay, and we're going to see what Dr. John Keil has to say about it. A young mathematician may be surprised to see the old obsolete elements of Euclid appear afresh in print. And that, too, after so many new elements of geometry as have been lately published, especially since those who gave us the elements of geometry in a new manner would have us believe they have detected a great many faults in Euclid. These acute philosophers pretend to have discovered that Euclid's definitions are not perspicuous enough, that his demonstrations are scarcely evident, that his whole elements are ill-disposed, and that they have found out innumerable falsities in them which had lain hid to their times. So I'm going to just interject a few comments. So he's referring obviously to other works that have been created which attempt to sort of renovate Euclid, to redo Euclid, to present that material in a different perspective, and he's not very happy with that. But by their leave, I make hold to affirm that they carp at Euclid undeservedly, for his definitions are distinct and clear, as being taken from first principles, and are most easy and simple conceptions, and his demonstrations elegant, perspicuous, and concise, carrying with them such evidence and so much strength of reason that I am easily induced to believe that obscurity Scolialists so often accused Euclid with is rather to be attributed to their own perplexed ideas than to the demonstrations themselves. And however same may find fault with the disposition and order of his elements, yet notwithstanding I do not find any method in all the writings of this kind more proper and easy for learners than that of Euclid. It is not my business here to answer separately every one of these cavillers, but it will easily appear to anyone moderately versed in these elements that they rather show their own idleness than any real faults in Euclid. Nay, I dare venture to say there is not one of these new systems wherein there are not more faults, nay, grosser paralogisms than they have been able even to imagine in Euclid. So he's pretty harsh here, isn't he? And I enjoy the language. It seems that these people are really on top of exposition and rhetoric, and there's a style and some kind of elegance in the way they use words that seems to have a little bit been lost in modern times, don't you think? Let me continue. After so many unsuccessful endeavors in the reformations of geometry, some very good geometricians, not daring to make new elements, have deservedly preferred Euclid to all others, and have accordingly made it their business to publish those of Euclid. But they, for what reason I know not, have entirely omitted some propositions, and have altered the demonstrations of others for worse, among whom are chiefly Tequet and Deschales, both of which have unhappily rejected some elegant propositions in the elements, which ought to have been retained, as imagining them trifling and useless, such, for example, as Proposition 27, 28, and 29 of the 6th book, and some others whose uses they might not know. Further, whenever they use demonstrations of their own, instead of Euclid's, in those demonstrations, they are faulty in their reasoning and deviate very much from the conciseness of the ancients. So you can see the importance of every single proposition of Euclid in his mind. These other people have dared to, fiddle around with propositions 26 and 27 or something in book 6, and that's sacrilegious from his point of view. And now we come to a very important point. In the 5th book, they have wholly rejected Euclid's demonstrations and have given a definition of proportion different from Euclid's, and which comprehends but one of the two species of proportion, taking in only commensurable quantities, which great fault no logician or geometrician would have ever pardoned, had not those authors done laudable things in their other mathematical writings. Indeed, this fault of theirs is common to all modern writers of elements, who all split on the same rock, and to show their skill blame Euclid, for what, on the contrary, he ought to be commended. I mean the definition of proportional quantities, wherein he shows an easy property of those quantities, taking in both commensurable and incommensurable ones, and from which all the other properties of proportionals do easily follow. Now he is making reference here to a very important book, book number 5 of Euclid, which these days is completely off the radar to modern undergraduates and graduate students of mathematics. Book 5 concerns the theory of proportions, which goes actually back to Eudoxus, which is Euclid's way of dealing with what we would call irrationalities. Okay? But Euclid did not deal with irrational numbers. He rather dealt with incommensurable proportions. So line segments whose ratio, whose comparability was not exact. In other words, you couldn't subdivide both line segments in terms of some smaller unit into an integral number of pieces. Okay? This is the geometrical way of thinking about what we today call irrationality. So book 5 is very important because it's an attempt to make rigorous this conundrum of irrationality, which appears to exist in elementary geometry. So if you have two segments, for example, say the side and the diagonal of a square, the ancients knew that these things were incommensurable in the sense that you could not find a third segment for which both of the side and the diagonal were multiples, were integral multiples of that third one. Okay, so this basic incommensurability is the way Euclid thought about what we would say is captured by the irrational number square root of 2, but he didn't think in that terms. But nevertheless, he wants to be able to deal with a theory of magnitude that incorporates these incommensurable ratios. And Eudoxus's theory does that, and it does it in a rather surprising and elegant kind of way, which even influenced Weierstrass in the 19th century. Okay, so, but unfortunately, this whole way of thinking about ratios and commensurability versus incommensurability has been lost to modern times. But you can see that Keil is very pointedly looking at this as an example of people going astray, of not appreciating sufficiently Euclid's deep understanding of what's really going on here. Let me continue with Mr. Keil. Some geometricians, forsooth, want a demonstration of this property in Euclid, and they undertake to supply the deficiency by one of their own. Here again, they show their skill in logic in requiring a demonstration for the definition of a term. That definition of Euclid being such as determines those quantities proportionals which have the conditions specified in the said definition. And why might not the author of the Elements give what names he thought fit to quantities having such requisites? Surely he must use his own liberty and accordingly has called them proportionals. So that's a bit hard for me even to understand. And I think he's talking about the use of terminology with regard to proportions. All right, so the next paragraph is a little bit involved, but I want to go through it just for completeness. It's referring to some arguments that other people are making, and so we don't really know what they are, but here is John Keil again. But it may be proper here to examine the method whereby they endeavor to demonstrate that property, which is by first assuming a certain affection, agreeing only to one kind of proportional, viz. Commensurables, and thence by a long circuit and a perplexed series of confusions do deduce that universal property of proportionals which Euclid affirms. A procedure foreign enough to the just methods and rules of reasoning. So he's being very snarky here, I think. They would certainly have done much better if they had first laid down that universal property assigned by Euclid and thence have deduced that particular property agreeing to only one species of proportionals. But rejecting this method, they have taken the liberty of adding their demonstrations to this definition of the 5th book. Those who have a mind to see a further defense of Euclid may consult the mathematical lectures of the learned Dr. Barrow. Now this is interesting. So now he's referring to a similar kind of defense by Isaac Barrow, who was a very important English mathematician. He was actually the teacher of Isaac Newton and has some claim to being one of the founders of calculus, perhaps even the first person to have discovered the fundamental theorem of calculus, as it's usually called. So this Isaac Barrow was also interested in defending Euclid, obviously wrote a book called In Defense of Euclid, that is now being referred to by John Keil. As I have happened to mention this great geometrician, so he's referring to Barrow, I must not pass by the elements published by him, wherein generally he has retained the constructions and demonstrations of Euclid himself, not having omitted so much as one proposition. Hence his demonstrations become more strong and nervous, his construction more neat and elegant, and the genius of the ancient geometricians more conspicuous than is usually found in other books of this kind. So this is high praise. I'm not sure where that term nervous, what usage that's supposed to mean. That seems incongruous, but anyway, that's quite interesting. So he's praising Barrow's treatment of Euclid and saying that, he's true to Euclid. He hasn't even left out one proposition. So you can see the importance of Euclid in these people's minds, right? It was important not even to leave out one single proposition. And we're talking about some of the leading mathematicians of the day here. These are not just minor educators. These are very prominent mathematicians themselves in the English landscape. To this he has added several corollaries and scolias, which serve not only to shorten the demonstrations of what follows, but are likewise of use in other matters. Notwithstanding this, Barrow's demonstrations are so very short and are involved in so many notes and symbols that they are rendered obscure and difficult to one not versed in geometry. There are many propositions which appear conspicuous in reading Euclid himself, are made naughty and scarcely intelligible to learners by this algebraic way of demonstrations, as is, for example, Proposition 13 in Book 1. And the demonstrations which he lays down in Book 2 are still more difficult. Euclid himself has done much better in showing their evidence by the contemplation of figures, as in geometry should always be done. Importance of diagrams. The elements of all sciences ought to be handled after the most simple method and not to be involved in symbols, notes, or obscure principles taken elsewhere. So having praised Barrow, but also criticizing him, he moves on. As Barrow's elements are too short, so are those of Clavius too prolix, abounding in superfluous scholiums and comments. So this is referring to some other contemporary edition of Euclid, presumably. For in my opinion, Euclid is not so obscure as to want such a number of notes. Neither do I doubt, but a learner will find Euclid himself easier than any of his commentators. As too much brevity in geometrical demonstrations begets obscurity, so too much prolixity produces tediousness and confusion. So we're almost finished. On these accounts, principally, it was that I undertook to publish the first 6 books of Euclid, with the 11th and 12th, according to Commandinus' edition. The rest I forbore because those first mentioned are sufficient for understanding of most parts of the mathematics now studied. So he's asserting that this is basically his rendition of Euclid, but he has left out the books that don't involve geometry, like books 7 to 9 and the 13th, I suppose. Further, for the use of those who are desirous to apply the elements of geometry to uses in life, we have added a compendium of plane and spherical trigonometry, by means whereof geometrical magnitudes are measured and their dimensions expressed in numbers. That's kind of interesting. So he's throwing in something else of his own, basically a treatment of trigonometry, which is connecting magnitudes, the magnitudes of the ancient Greeks, to numbers. So this is all very interesting. I hope you've enjoyed it. I think this sheds light on why it is really important to understand what Euclid has been doing. So to appreciate the trajectory of pure mathematics over its at least maybe 2,500 year history, maybe more, going back to the Babylonians, we have to appreciate the dominance of Euclid for more than 2,000 years, even though that dominance has dropped off dramatically in the last century. Okay, but some of the issues that Keil is referring to here actually are going to the heart of even some of the modern difficulties with the foundational aspects of pure mathematics. I'm Norman Wildberger. Thanks for listening.